Bismillahirrahmanirrahim. Assalamu alaikum. Dear students of class 12th, today our topic will be force on a current. Let you see, we have a current PQ of area of section E and current flows through it. A current I flows through it. We have found magnetic Lorentz force that when a charge moves in a magnetic field, then it experiences a magnetic Lorentz force, that is QV by QV P equal to QV cross B. Now, in case of current, electrons move in the direction opposite to the convection direction of the current with velocity, with drift velocity, that is Vt. So we considered here, so charge electron, when current flows, that is charge moves. When charge moves, when that current conductor is put in a magnetic field, that will experience a force, Lorentz magnetic force. We will find the expression for that force. So consider the straight conductor PQ of length L carrying a charge I placed along y-axis. Let the magnetic field be acts along z-axis. The current through the conductor I is equal to NaEVd, where N is the number of free electrons per unit volume, A is the area of concern, E is the charge on the electron, and Vd is the drift velocity. As the flow of the convection current opposite, thus we will see that if a multiple current element, that is current into length IL, is equal to minus NaLEVd. Here we multiple the above equation, I is equal to NaEVd by L. So we will get current element, that is a vector. Current element is a vector which is product of current and the length and is directed along the direction of the convection current. So negative here is that the velocity is opposite to the direction of the current. Now magnetic force for moving on is equal to, that is charge into V cross B, here charge of electronic. So if we add free electrons, then the total force will be N, force on the N electrons, that is N into F. Now N is equal to, it is volume into number density of free electrons. So it is NEL. A is area of crossing, L is length. So area of crossing into length, that is volume. So NEL is equal to N, that is total number of electrons. So we will get NEL minus EVd B cross, because F is equal to minus EVd into B cross. So it is equal to minus NEL EVd cross B. Now from equation first, minus NEL VD is equal to IL. So from equation first we get F is IL cross B. IL. So this is the relation. Force on a current carrying current will be equal to IL cross B. Now magnitude of the force will be BIL sin theta. So theta is angle between. So this force, apart from depending on the magnetic force and the current, it depends upon length and the angle the current carrying conductor makes with the magnetic field. So when theta is 0, that is current is parallel to the magnetic field, sin theta is 0, so we will have 0 force. So when a current carrying put along the direction of the magnetic field, it will experience no force. And if the magnetic field is perpendicular, then the theta is 90, so it will experience a maximum force. So if you want a maximum force, we have to put the magnetic field, we have to put the coil, we have to put the conductor perpendicular to the magnetic field. Direction of force will be given the vector current element cross B. That is the direction of the force will be perpendicular to the current element, plane containing current element and the magnetic field. So if current element is along z-axis and magnetic field current element along x-axis and B along z-axis, then the force will be along x-axis. It can be also find right hand thumb rule. So if we move our fingers, point our fingers from direction of current to the direction of magnetic field, then the thumb will put in, give us the direction of the force. Thank you.